So we're asked to find the percent under the curve. We're trying to determine, I've got my mean is 0. It's a normal model. My standard deviations obviously are 1. So mu is 0 and my sigma is 1. So we're trying to determine an area under the curve, a percent under the curve. Now, you should be able to divide this into parts and tell me the 34%, the 13.5%, the 2.35%, and the 0.15s. Okay, so we're looking at that concept and using that, but we're first going to determine, okay, I have this drawing, so I'm curious, what percent of the graph is between, let's just pick a raw number, and I'm going to say I have a z-score of 1.67. So I have a z-score of 1.67. In other words, somewhere right around through here. And I want to know what percent of the graph is to the left of that. I want to know what percent of the graph is to the left of z-score of 1.67. So to determine that, we can do one of two things. We can use the table in the back of the book, find the z-score, and from that z-score, we could then pull up our table. Okay, so we see our table here. Oh, you don't see my table. I forgot. This does not go that way. So we won't do that. We'll go strictly with using a calculator. So we'll just use the calculator. So we're looking at, let me turn that light off. We're looking at a z-score of 1.67, and we want to know what is the percent of the curve is from a negative infinity way over here to the left to 1.67. So to determine that, I'm going to go to second distribution. Okay, right here above VARS is DISTR, that stands for distribution. So I go second distributions, and that gives us these numbers. Okay, the one I'm looking at here, there's normal. We have a normal model, these first three, normal, normal, inverse normal. So we're looking at normal models. And so it has normal PDF. Normal PDF is a percent that exactly where we expect a number to fall. What percent of the time will it fall there? Whereas a normal CDF, that C stands for cumulative. Cumulative means everything added together. So that's what we're looking for, this total shaded area. Okay, this is number 2. We go second distribution, and then we're looking at the second one here, normal CDF. So I'm going to press enter. Now, here it says my lower number is a negative 1e to the 99th. And if we think about it, these numbers are getting smaller and smaller. Negative 1e to the 99th is way that way, way out there. That's like saying a negative one Google, way out there. It's a very minute number. So instead of doing that, you can leave that on there because it's already there if your lowest number, but you could also use this as a negative 1,000, 100, negative 10, anything way past our negative 3 number here. And so we're going to go right now with negative 1,000. So what is my upper number? Well, that's the number that's given to me here, 1.67. So because we're looking, the lowest number is way over here, my biggest number is right here. That's 1.67. Now, what's the mean of my data? It's 0. It's already written here. My sigma is 1. So we paste. Okay. There is our normal CDF. 1,000, whoops, getting glare, 1.67, 0, and 1. So I enter, and that tells me that 95% of the data, 95.25, but I'm going to say 95% of the data falls to the left of 1.67 standard deviations. Okay, 95% of the data falls to the left of 1.67 standard deviations. So that makes this a z-score of 1.67 is the 95th percentile. Okay, that means 95% of the values are lower than this z-score. So if you have a z-score on a standardized test of 1.67 standard deviations above the mean, means you scored in the 95th percentile. All right, let's look at another example of this. Let's say we want to find between what percent of the graph falls between, and let's just do an easy one, between -1 and 1. We already know this number, so we're looking at these values right here. At least you should know this number. What percent of the values fall between -1 and 1? Again, it's a cumulative addition. We're finding all of these numbers here. So second distribution, and normal CDF. So what are my numbers between? A -1. So I type in -1 on my computer, and 1. Again, my 0 is my mean, 1 is my standard deviation, and I paste that. So between -1 and 1 standard deviations, what percent of the graph is there? Well, look at what it says. A little over 68%. So 68% of the graph falls between -1 and 1. We knew that. Really, it's 68 and some change. So really, our numbers aren't exact, but it's good enough for government work and what we're doing right now. So to determine percent under the curve, we use second distribution, and we're using PDF and CDF. Now, so far, we're just using CDF because it's cumulative. We want all the area under the curve. How do we get there? Second distribution, the second one, and we plug in the numbers we want to find. I hope that works for you.